Okay, good. So I think so far we've done quite some things. Should be enough to get introduced to C++. Now it's starting to get to see the real power of C++. I think when we started, we defined what variables were. So we had variables. Sorry, variables. I didn't spell that right. We had varies. Okay. So we defined what those were, and also looked at control structures, selection structures. Just a minute. All right. So selection structures. We looked at if-else statements under selection structures. So it's, if-else, how computers make decisions by comparing. And also looked at the catch, switch case. Sorry, catch is something else. Switch case. All right. There's another kind of if-else statement of selection structure. It's called the Elvis operator. Most programmers just call it the ternary operator. We'll explain more on that. Not today, maybe later on in another session. But today, what we're going to look at, and then we've also looked at loops and repetitions, right? Okay. How you can perform the same action over and over again. Maybe just adding one to a number. I can do that over and over again. But today we're going to look at something else, functions. Or something called functions. Now, every C++ program we've written so far, we had something called include IOStream, to the point where you almost think that every C++ program should have include IOStream, but no, it shouldn't. Not every C++ program is supposed to have include IOStream. Let me just let someone in. Okay. So not every C++ program is supposed to have include IOStream. You can have any other libraries out there, and if you pass through the loops videos I've made, you've seen how I've used cout, CMath, and IOmanip. You can use any library. There are lots of libraries. So you want to use input output stream if you want to work with cout and cin. Cout and cin. Right. And then after that we defined code using namespace std. So we use the namespace. Our namespace is part of the standard library. That's what std means. Okay, std. And this also contains the definitions of input output, cout and cin. Okay, now we're now interested in this part, int main open bracket. So we've been writing all our code in this thing called int main, and here it said return 0. Again, it's not compulsory to use return 0. It's just recommended that you use return 0, but it's not compulsory. But this is called a function. Now this one is a special kind of function. It's main, of course, it's the main function. It's the main thread. Main thread. So to run any C++ program, you need the main thread. You have to call it somehow. So you can forget this. This is not compulsory to have in C++ program. You can forget that, but you need to have main thread. Remember we talked about a compiler, and we said you write your code in C++, which is human readable English code, yeah, and then you're converting that English code to ones and zeros, which is binary code, right? Okay, so you're writing your code in C++, human readable code, English, but then you're converting it to binary code to machine language. You have to convert it to machine language. Right. What converts that machine language is something called a compiler. Compiler. Com- So in the compiler setting, it starts from an entrance point, and that entrance point is always a function called main. So there's only two versions of main function. There's this one and another one, which is sorry, int main car and the pointer. We explain what the pointer is when we're doing memory allocation and there are more. But there's only two versions of the main function. The one you're going to see mostly is this one. So every function, every program starts its execution from the main function. Now, what's the function? That's what we'll be looking at today. We'll be defining what a function is. So, at most basic form, a function is just a block of code within these braces. That's what it is really, it's just a block of code. So you can organize the code and then you put it within these braces. And when you're starting, the compiler calls main function, and then think of main function to be the engine, okay, of your car. Everything is driven by that engine or the main control unit. Just a minute. Okay, so think of the main function as the engine for a car or anything else. I'm not sure. Or the main control thing. So main has to call any other function defined. So it has to be called. So int main, and then a function is just a block of code. But then this int main calls all other functions. So you can make other functions in here. You can call them underscore main. Call them or invoke them. Okay, we'll see what that means when you're writing code. But yeah, you can call a function. So basic structure of a function, I'll just say structure. You have a data type, a return data type, return data type. You have the function name, and then you have the arguments. Arguments. The arguments are also called parameters. Parameters. Really, if you love math, which you should, because we're engineers, functions won't be that hard to understand. Because in math, we have a function. We call it f of x, and we call it maybe, let's say, it's the hyperbolic sign. Maybe, let's try hyperbolic cosine of the sine inverse of x. Okay, this is the function. Yeah, and then this is argument. Then later on, we also learned that we can have multivariable functions and doing multivariable calculus. So you can say f of x comma y. Maybe this is z is equal to f of x comma y, and I'll just draw out a circle to be more straightforward. Maybe I say it's a cylinder of some kind. So we know the value of z depends on both x and y. That's the multivariable. Now these are the parameters. Parameters. Or if you want to call them arguments. Arguments. Okay, so you're going to get multiple values of z depending on the values of x and y. And then x and y in math, they can be anything. In C++, all you're doing is just you have to identify the data type or specify what kind of data type x and y are. Okay, now that that's cleared, let's try some code. So I'm going to stop sharing this board and then I'm going to go to share my code ID. So I think I'll be using, I've used Visual Studio Code quite a lot. Let's try to use Dev. So I'll just stop sharing that. I just realized I can't share Dev for some reason. It fails to be shared. Okay, so I'll just use Visual Studio. Just a minute, I'm not yet sharing my screen, so don't panic. Right, now I'm sharing it. Just confirm if you can see it. Right, I can't see any text messages from this side, so I'm just going to assume you can see it. If you can't see it, just say something. Don't text. Sorry. Alright, sure. I'm getting a yes. Yeah, so if you can't see it, just turn on your mic and say you can't see it. I won't be able to see it text from this side of code. Okay, maybe I should make that huge. I think someone else joined and just confirmed. Alright, sure, you're welcome. You can still follow along the code from the recorded session if you missed out the first part, so don't panic. Okay, so this is some code I was writing on making some triangles and some shapes. You can check out this code and the video on the Google Drive. But from here, let's try to make a new file. I'm going to name it functions.cpp. Okay, functions.cpp. So I'll say, don't forget to comment. So just say, this introduces functions. Again, have to include IOStream. Again, as I've stressed, it's not compulsory that you have include IOStream. It's only compulsory if you're going to use C in and C out, but then you're going to use include IOStream in all your code you're going to write in the exams and tests and everything. So just get used to it. Int main. So this is the function. It's called main, right? It's called the main function. But then to define, and I can print out anything here, say hello world, what is side of it? Okay. So it's hello world, terminal, new terminal. I'm just going to run that. That's going to be G++ functions.cpp. Sorry for that. Okay, so there's the main function. It prints out hello world. But let's say I don't want to print out hello world from main. I want to do it somewhere else. So I define a function, and I can call the function anything. So return data type will be void. Now what does return data type mean? It just means what value the function is going to return to the function which calls it. I'll explain what that is. That's right. So that will be hello. It won't accept anything, and all it will be saying cout hello world. And okay, so I've defined a function. On top, it's hello, and this value is cout hello world. It's what's now printing out hello world. So here I'm just going to say hello. I'm just going to call the function. So to call the function, you just type out the name of the function with parentheses. Okay, if there's any parameters, you put the parameters in there. But that's valid code. That's done. And the goodness is this that you can define this even in another file. It can be a header file, different file, if you want to work. Okay. So I'll say cout new terminal. I'll just say G++ functions.cpp. Okay, that runs. E.exe. There goes. I'm printing out hello world. Okay. So all I did here is just call this function hello, and what this function does is this. Okay, so here you have the return data type. The function is void. The name of the function is hello. The arguments, it has none, no arguments, and then it's printing out hello to the calling function. So imagine instead of putting hello here, imagine the block of code, whatever block of code can be in here, to be in main. There. So here you can add anything really. You can say cout what is your name. So just make a variable for the name, string name, and then you enter out the name. So cin name, and then just say out, nice to meet you. So for that, nice to meet you name. Oh, I have an error here. So just compile G++ functions as cpp a.exe. Okay, hello world, what is your name? My name is Aaron. Nice to meet you, Aaron. Okay, nice to meet you too. But so that's what I'm doing in main is just calling out hello. And then I have this block of code here. Now the goodness with this once again is that you can define this anywhere. You can make a new header file. Let me just try this. We'll learn how to make our own header files later on, but let me just make a header file. Let me just create my header.h. That's how you make a header file. And then I'm just going to don't mind this. Um so that's called a macro, but don't mind that. Sorry. Okay. Then here I'm going to include IOStream. And then I'm going to should I use okay, say using namespace. Let me not choose namespace yesterday. Let me just show that I can still use something other than namespace yesterday. Yeah. So I'm just going to say paste out that function. Now that is linked to the Google Meet. And just go here. So I have this block of code. I'm going to cut it out and do. I have this block of code. I'm going to cut it out from here. Okay, then from here I'm going to make it there. So okay, to avoid complications, let me just use namespace std, although you can still do std like that. This is the more recommended if you are making for a game or anything, but here we just say using namespace std. Okay, the errors go away. Let me go back here. I've made a new header file, so here I'll just say include. I'll include the header file. Include my header.h. Okay, there goes. Now the header file has a function called hello. So let me just write void hello like that. Why is it giving me an error? Just a minute. I think I'm going to go back here and I'll use GitHub. So there goes. I have made my own header file. I've called it my header.h. I've made my own namespace in another file, and then here I'm just writing a new C++ file. Looks like this. So what I'm doing here, I'm just going to run it again, and you see it's going to run. Can you let me know? If don't worry if you don't know how to do this. We're going to learn it hopefully together, but it's not necessary. If you just want to learn it, then I'll be more than happy. Okay. What am I missing? I don't have an error. I've made a namespace. I'm missing that. But anyways, the gist is that you can make your function definition somewhere else. As you can see, I'm not getting any error here. I've made my function definition in the header file. This header file, I've just made my own header file. So don't mind that. That's how you make a header file. Don't stress if you don't know how to do that. Yeah. And since my header file even includes IOStream, I can even remove IOStream here. So this is a valid C++ program. I think just because of Visual Studio Code, it should run. I think it's just complications with Visual Studio Code, but then as you're seeing, I'm not having errors. So this is a valid C++ program, which, yeah, there, it does compound, and I'm going to run it. Hello world, what is your name? My name is Aaron. Oh, nice to meet you, Aaron. Now, just to show that I can add anything to my function, let me add something else. Let me say Seattle. Where are you from? Um, where you from, right? And that's a question. So every question needs an answer. I'll have to make a variable to store that answer. Let me create a string. I'll say response, and just say C in the response. And you just say out. Wow, nice to know that you are from. I don't know. I'll print out the response. Nice to know that you're from. Whatever response you give me. Okay. I'll go back to this and we'll compile and run it. So I'll say new terminal. Terminal. Okay, that's the compilation compiled. Hello, what's your name? My name is Aaron. Or nice to meet you. Where are you from? I'm from, let's say, Lusaka. Alright, nice to know that you're from Lusaka. Okay, so I hope that stresses my point. I'm not always supposed to have include IOStream. Now, by including this header file, I also included, I've already included IOStream. This this is a personal made header file. You can make your own header file, you can include it, but this is a valid C++ program. This is valid, and as you've seen, it's managed to run. Then I also made my own namespace. I called it namespace, my namespace, and I just said using namespace my namespace. That function hello is defined in this namespace in another header file. Okay, so that's the goodness of functions. Your code doesn't have to look all messed up. You can just call that block of code. So imagine here where there's hello. I'm doing all this. That's what the function is. Okay. Then calling a function is just writing out the name of the function. So just writing out hello. Now I can make another function. That's the goodness, right? That's the goodness of functions. I can make another block of code. Let's say void. This one is going to ask me for my edge. Okay. And also going to say start how old are you? And then I'm going to enter in an age. Of course, I'll use another variable. Maybe let me just say ag. It has to be different from the name of the function. I'll just say int ag. I define it. I'll say out. Wow, nice to know that you are ag. And okay, so this is being done in another file. It's a header file, which I've included here in my C++ code. So all I'm doing here, I'm just going to say, let me call edge first. Edge. Now it's valid because edge is in my namespace. So I can still go there and say new terminal. So I just say g++ function.cpp. That compiles to run it here, say a.exe. Okay, hello, what's your name? I'm Aaron. Oh no. Okay, nice to meet you. Where from? Let me say that. Okay. I'm just going to save that because I didn't save it. So the edge function also works. That compose and run it. How old are you? Well, let's say I'm 15. Nice to know that you're 15, and then ask me what's my name. Okay. Of course, I'm where I'm from. Okay, cool. And that's what functions are. So this is valid C++ code. As you've seen, it's working, it's compiled, everything. But this is what functions are. Instead of having to write out blocks of code here, I can organize them into functions. So here where there's edge, what I have is this whole block of code. This block of code comes here where there's edge. So I can remove edge, I'll put that block of code. And then here where there's hello, I'm just going to comment out edge. Where there's hello, I'm just going to comment out that. Comes in this block of code. Copy, I'm going to go back to functions with CPP and I'm going to paste that. So that's what functions are. This is the edge function. This is the hello function. That's what they're doing. But instead of writing out all that code, I can write it out somewhere else and then just call it. Okay, but then for this session and really for our course, we will be doing the definitions and calling in the same file. So when we're making our own header files, I'm just going to delete this header file. I'm just going to delete that header file. Sorry, that's not there. Why did I make it? Oh, it's right here. Okay, I'm just going to delete that header file. There goes deleted. I don't have it anymore in memory, so I'm going to get an error and just delete this whole block of code. So let's start again. This introduces functions. Then I have include IOStream using namespace std. Just can say int main. Okay, so you can let's make the same functions. Now let's make them in the same file. So something you have to know about functions, it's recommended to put your function prototypes here. So function prototype. So a function prototype is really just what the function looks like. That's like the return that type or return type, the name, open bracket, the argument. So you put those on top and you define the function here down. So down you have function definitions. Okay, let me show you what that means. Let's do the same functions every day dealing with edge and hello. So those functions, all they're doing is just printing out something. So I'll just say void edge. That's a function. So that's the dash type. What it's going to return is void. The name of the function is edge. Okay, and we're going to have another one void hello. Okay, so that's the function prototypes. Then at the end, I can define them void edge, and I'll give them how they operate, and I'll tell them how they operate. So this one is asking for my edge. Int edge, I'm just going to see out how do you, and they'll see in edge, see out. Oh, nice to know that you are. Am I missing something? Okay, nice to know that you are edge years old. And here you can just say return if you want. If you want, you can just leave it. Okay. So I use another one, void hello. Here we're going to say see out. Let's just say how are you. Okay, then I'll just put text, maybe just make it look interesting. This is the edge function. Now, just quick trick. Another way you can go to the next line is just saying that. So here I'm printing out two blank lines, and then here I'll just say see out. This is the Let's just hello. Sorry for that. This is the hello function. I just say that and okay, I'm not going to get input from the user. So that's functions with CPP. Right. So as you can see, it hasn't output anything because there's nothing in main. There's nothing in main. So I have to make some code in main or have to run some code in main. So again, just emphasizing that execution is always in main. Main has to call the other functions. Think of main as the main driver. Okay, so I'm calling edge. I'm calling hello. So I'm calling out those blocks of code, right? Edge and hello. Okay. Let's say terminal, new terminal. I can now compile that. It's going to run nicely now. Okay, this is the edge function. How do you have 16? When I know that you're 16 years old, and then you have the hello function. How are you? Okay, so as you can see, it's one block of code after another. Yeah, that's really about functions, an introduction to functions. Now let's get things more spiced up a bit. Okay, probably these functions aren't interesting really. You may have functions, maybe let's say, and find the square of a number. Okay, so I'm just going to make other functions. So let me just delete this block of code. So this maybe I'll still say this introduces functions, and I'll include iostream using namespace std. Then I'll have the square of a number. Let that be a double. Okay, I'll say that double or sorry, up to anyways. But let me just assume a square number. I'll say square. So here you get a number which should be a double point, and return a number which is a double point. That means double floating point. So let's see what that means. Int main. So I'll say number double number is equal to 0. Then you ask the user cout. Oh no, sorry, cout. Enter a number. Okay, so they're going to enter in a number, and you're going to call the square function. So now you're going to make another variable. Let's call it double sq. That's fair enough. And then you're going to say sq is equal to what the square function returns when it gets in number as an argument. Okay, so the square function is going to get in number, and it's going to return a value, and that value is going to return, it's going to be double point, and it's going to be stored by sq. That's what that means. Say double square. I'll say double number. So this is the function definition. Okay, so here all you can do is, I'm trying to avoid the first method because we're just beginning. So I'll just make another variable saying double squared. Okay, now say squared is equal to number times number. Then you return squared. That's what the return statement means. Return squared. So when this function is called, it returns to the calling function squared. And what it returns will be stored by sq. So just say cout the square of the number is squared. Cool. Here you can say return 0. Sorry, it's called sq. Return 0. And the people who've been saying return 0 is because of this int here. Main has to return an integer. But if you forget to add return 0, for main it's lenient because it's made by the C++ developers. so they just add it for you in the compilation. But for these other functions, if you say double, it has written a double, and you don't return a double here, it's going to give you an error. So if you don't return anything, or you expect it to return, it's going to give you an error. Now you may ask, we had voids in the previous statement, and it didn't return anything. So that's because void is nothing. So if you have void for the return data type, and you don't return anything, then it's still going to work because nothing is equal to void. Yeah. So let's try. I'm going to compile that. I'll just say G++ function to cpp a.exe. Oh no, I'm still running that other code because I didn't save this. So I'll save that, then I'll compile it. Okay, enter number 5. The square of the number 5 is 25. So notice what has happened. All I've done is just call this block of code squared, and then it got an argument which is x. Think of it back as the math part we did. In the math we had f of x is equal to x squared, or f of x is equal to x times x. So think of the x. This here is the x. And then what you're returning is the value of f of x, which you're storing as sq, or in this case sq. Okay, that's the power functions. You can do more things. Let's make another function which is going to return a length. So we're going to use maybe Pythagoras theorem. We'll be given two numbers and then return the length of the hypotenuse. So let's say C out. That would be hypotenuse. How do you spell that? I just say hypotenuse. So two numbers will both be doubles. Okay, like that. So of course we're going to have one for the square, and then we're going to have double. Let's make a length variable. Okay, then I'm just going to ask in main function, enter a number. Now one thing about entering numbers in consecutive, you can just say enter two numbers. So I can just do this one after the other. Okay. Here you can say the length of the triangle. Assuming it's a right angle triangle. The length of the triangle. So double length, and then you say double A, comma B. These are going to be entered by the user. Then you say C in A dash 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 B. And then all you're doing is calling this function hype. Okay, so you say length. This function return a value. Length is equal to hype. Then input these numbers A, comma B. Okay, there goes. So you say double hype double. You can call them anything here. A double B. It's up to you what you like to call them. Okay, I'm going to use CMath because I want to call some functions from the C++ math function. So CMath like that. Okay. Then I'm going to say double length. Now this is a local variable. It's local to this thing. So even if I code it length in here, it should be different. Then here I can say cout in main the length of the hypotenuse. I think that's how you spell it. Whatever. I'm not sure. I'll check. Is length. Yeah, let's just say NL. Okay. So double length. What's the length of hypotenuse? So the length is equal to the square root. So I'm going to use the square root function from C++. of a squared. So a squared is a times a plus b squared, which is b times b. You can do it like that if you want to. Or if you want to, another alternative, I'm just going to comment that out because I want to use it. You can say length is equal to the square root of a to the power 2, a to the power 2 plus b to the power 2. Okay. Then after you're done with this, you just return length. Okay, so we're going to use most commonly known. I think we know 3 and 4 always give us 5. 4 squared plus 3 squared is 25 squared root, that is 5. So I'm going to enter in my two numbers, 3 and 4, into here. So just make sure I save that. And I'm going to run that. Or enter number 7. The square of the number is 49. Into two numbers. Now remember we're entering them consecutively. So you can say 3, enter. It's going to wait for the other one, 4. Okay. The length of the hypotenuse is 5. So that's the power of functions when you can have blocks of code. Now introduce another notation to code them. To use that, if you don't want to use that, this is more preferred because you can have maybe another power instead of squared. Okay, so you don't want to, let's say you have the power 4, you don't want to say a times 4 times 4, a times a times a 4 times. You can just say power a comma 2, a comma 4. Okay, I'm just going to compile that in a run. The number I'm going to enter is 8. The square of 8 is that. I'm still going to enter my 3 and 4. Okay, the length of the hypotenuse is 5. So just to show it works, I think 8 and 6 also give us 10. So I'm going to say 6 to square is 6. I'm going to say 6. Now if you don't want to use enter, you can just leave a space and then say 8 because I'm entering them consecutively. So it's just going to store them different. So the length of the hypotenuse is 10. So this is stored in A, that's stored in B. Okay, that's the power of functions. So you have a function prototype. Here, this is my function prototype. So it's just spelling out what the return directory for the function is. That's the double, the name of the function is square, and then what are the inputs or parameters of the function. So I have double, and then here I have double, the name of the function is hypotenuse. The parameters double, double. It's going to get in two numbers, both going to be doubles. Okay. And all I'm doing is now calculating these values from these functions. So the main function is calling this in. Now sometimes you may not even want to do any of this. You may just want to have main clear and clean. Okay, so do that. You can say you may even put all this block of code. Sorry, let me just undo. This whole block of code in the function. I'm just going to cut that. And I'll just put that whole block of code in the function. So when main calls this function, it's just going to start running. Okay, so I will just find that copy. I still need a way of storing what it returns. Okay, then this also. I'm going to cut it out. X. Oh no. 7. I can do this here. So cut that out. I wasn't supposed to cut this. Cut that out, and then I'll paste it here. Cool. So you can do my definitions in the function, although it would mean I wouldn't have to enter any of these. So I change the definitions. I don't have to enter any of this, and that would be boring. I'm just going to do it for square, I think. Okay, so I can do my definition here. Double number. Okay, so it will not have any argument, and I'll change the prototype also. It's not expecting an argument. Cool. Alright, cool. Let's see how that works. New terminal. It's going to say g++ functions.cpp and a.exe. Enter number 5. The square of number 5 is 25. Into two numbers. I'm going to enter 5 and 6. Okay, the length of the equation after that. So that's the square root of the sum of the squares. Okay, that doesn't look nice, so I'll just go back to what we had. Okay, sure. Sorry for that. So yeah, that's that about functions, how you can use functions, and that's really a brief introduction to what functions are. So they're basically just a way of storing blocks of code which are going to perform the same operations over and over again, and then you're storing them so that you can call them from any place you want. So when you want to perform that operation, all you have to do is just call that block of code. Okay, and then for today's feature using functions, what we're going to do is let's make a function which returns a factorial. So it's just going to return factorials of numbers. I'm just going to say factorials .cpp. Okay, so say this program returns factorials. IOStream using namespace std. I'll make a function called now factorial is an integer, so I'll just say int factorial. It will have an integer input, int number. Oh no, let me not do that. So int factorial, and then it's expecting to have an integer input. So int main, I'm going to make a variable to an integer to be fact, and I will initialize that to 0. It doesn't matter, it's initialization. So fact, if let me say factor is equal to factorial, what this factorial function returns. Okay, now you do that after enter a number. So it says cout, enter a number. You tell the user to enter a number. So cin and they'll enter a number. And just say int to make a variable called number. Okay, and then I'll just say I'll call the factorial function. So factor is equal to factorial number. And I'll just say cout the factorial of the number is factor. And cool. I'm going to go back here and define it. So this is the function definition. Alright, so how do you get a factor? I'll use, there's a better way to get a factor using what's called recursion, but then we're just beginning with functions. Let's just use a for loop. So using a for loop, I'll just call that initialize is equal to 1. That will be an integer. Then I'll say int, I'll use a for loop. So for int I is equal to 0, I is less than number, Now I had we have started 1 less than or equal to number, and then I plus plus. Okay, fact is equal to fact times I. Then just going to return that. Okay, and that's going to work. So when you call this factorial function, it runs this block of code. Then it returns the factorial that's stored in factor, and that's printed out there. Let's try to run and see how it goes. So I will. This is a new file. I called it factorials.cpp. Okay, to run it, just say edit exe. So enter number 5. The factorial of the number 5 is 120. So let's enter another number. Let's say 6. Factorial of the number 6 is 720, which we know is correct, right? Because we're engineers. Okay, and 24. So that's really all that's happening. I'm having a function, and that's storing all this block of code. So I'm just calling out this block of code repeatedly. Okay, now I can even be cooler than this. I can print out in one for loop. If I want to print out factorials of numbers from 1 to 10, I don't know if that's going to work. Let's try it. From 1 to 7. So just say for int I is equal to 0. I is less than 7. I is I plus plus. Okay. Then I can just say cout factorial I. So that's going to be the factorial of I. So I'm just going to start at 1 because we know the factorial of 0 is 0. I'm going to remove this one here. And okay, let me just add back. Undo. Just add it back. Okay, sure. Alright, there it goes. So let's run. So this should print out factorial of numbers from 1 to 7. Compile it and run it. Enter number 5. Okay, the factorial of 5 is 120. I have 126 now. That's not so clear to see. So I'm just save that and then I compile it again. Okay, 5. And then our factorials of 5 is 120. Then factorials of numbers 1 to 6, 24, 120, 720. So that's what's happening there. I'm calling out this block of code continuously, and then this I is the argument number. Yeah, that's the Tuber's introduction to functions. I'm going to send out more videos on the Google Drive, just how we can practice these functions and what we can do, how we can answer a few exam type questions, and also just like programming questions in general. I don't know if anyone has a question.